Hi everybody, Mrs. Danielson here, and today we're going to talk about the law of exponents. For many of you, this could be a repeat of things you've learned earlier, maybe in junior high, but we need to review them because we are going to be using our law of exponents quite a bit as we head through pre-calculus. So we're going to review them today, and then we'll be ready to make them a little more complex as we head through the curriculum over the next couple of months. So let's review our law of exponents today. First, let's go right back to the beginning so we make sure we're all on the same page. The first thing for the law of exponents is what does it mean when we have a number that's raised to an exponent? So let's go right back to the beginning. Let's say we have a to the n power. What does that represent, right? Well, that represents n a's, right? That means we have a times a times a times a. Well, we have a multiplied n times, right? That's what a to the n represents. Okay, one thing that we had kind of struggled a little bit with when we're doing exponents, and I just want to make sure we knock this out right now, would be if we have a negative number to an exponent. We have to be very careful with that. So let's say we had -2, say, to the 6th power, right? That is -2 6 times, right? So that's going to be -2 times -2 times -2. We're going to do that 6 times. And that's going to equal 64, okay? But it's totally different problem if you've -2 to the 6th, right? Where that -2 doesn't have parentheses around it. Okay, that's going to be a totally different answer. That's not -2 6 times. That is negative times 2 6 times, right? So our answer, 5, one more time, is not 64, it's -64. And we get a lot of mistakes and a lot of errors right there. Like you could do a really complex problem and then end up with the wrong answer just because of whether or not there was parentheses in the exponent problem or not. So just be super careful as we go through these problems in this particular unit to pay attention to where your parentheses are, okay? All right, so let's go ahead and start looking at our exponent laws. Okay, the very first one we're going to look at is a really great one. We love it, and that's the zero exponent law. Okay, so the zero exponent law. We love the zero exponent law. It makes our life so easy. The zero exponent law is going to be if you have any base to the power of 0. Okay, any base to the power of 0 is going to result in 1. Okay, so let's go ahead and just put that in there. It doesn't matter how complex that base is, you're going to get 1. That's what's glorious about this law, right? So I could have like, I don't know, we could have like 1 to the power of 0, and that's going to equal 1. But I could also have like something really super complex in there. I could have, say, the square root of 3 minus pi to the power of 0, right? That's a lot more complex. That would still equal 1, okay? Any base to the power of 0 is going to be 1, okay? And that's our zero exponent law. That's our favorite one, right? We love that one, okay? Wish we had it more often than we do. Okay, our next law is going to be the negative exponent law. Negative exponent law. You should already be familiar with these laws, right? We're just kind of reviewing for right now. Okay, so the negative exponent law is going to be any base number to a negative exponent. You just take that base number and the exponent, you move it to the other side of the fraction, and you make that exponent positive instead of negative. Okay, that should be pretty familiar. So say I just had like, let's say x to the -1 power, right? Then I would just move that to the denominator and make that one positive, right? Or 1 over x. Same thing would be true if you had, say, the negative exponent in the denominator. Like let's say instead it was 1 over x to the -1, right? So to change that -1 to a positive, you just move where it is in the fraction, right? So you move it to the top and make it positive. And so now you'd have x to the 1 or x. Okay, so that negative exponent just means move its location in the fraction. Okay, now when you're simplifying our problems that have exponents, don't ever leave that negative exponent. It's not fully simplified until you get rid of all the negative exponents. Okay, never leave a negative exponent in there, okay, or it's not fully finished and you'll get points deducted from your work. Okay, so get rid of all the negatives. All right, the next one we're going to talk about is the product of a power law. Okay, product of a power law. And that one is if I have a base number to an exponent and it's multiplied by that same base number to a different exponent. Okay, then what you can do is you can just add those exponents together and combine them. Right, so instead you'd have that base number to the m plus n. Okay, so an example of that would be, say, 3 squared times 3 to the 5th. Okay, you can just combine those and make it 3 to the 2nd plus 5th, which would be 3 to the 7th. Okay, so for that to work, to be able to use that law, you just have to have the same base number, right? It wouldn't work if it was 3 to the 2nd and then 5 to the 5th. They both have to be 3s, okay? For this law to work, they have to have the same base, okay? The next one is your quotient of a power law. Okay, same thing, you have to have the same base in the top and the bottom, but if we have a to the power of m and a to the power of n on the bottom, okay, then you can just simplify that, use that same base, and then it's m minus n, like that. Okay, so if we go ahead and use 3 as a base again, let's say we have 3, let's say we have 3 to the 5th divided by 3 squared. Okay, then you can just subtract those powers, and it's 5 minus 2, which is 3 to the 3rd. Okay, again, you can't use these laws if they don't have the same base, right? A 3 on top and a 3 on the bottom. Okay. Okay, our next one is power of a power law. This one's great. This one, because otherwise problems can be kind of complex, but if we can use this law, it does help us simplify them. Okay, this one looks like if I have a base raised to a power, and then there's another exponent on the outside of the parentheses, right? So this is where our problems are starting to get a little more complex here, right? Then you can just multiply those exponents, right, and combine them into just a single exponent. Okay, so if I had 3, the 2nd power, and then that whole thing is raised to the 5th power, then I can just make that 3 to the 10th power. Okay, so it's getting rid of some of those parentheses, trying to simplify our expression, okay, using the power of a power law. Okay, 2 more. Okay, so we've had, how many have we had so far now? We've had 5, I believe, right? We've had the 0 exponent law, the negative exponent law, product of a power law, quotient of a power law, power of a power law. Okay, and just to remind you again, right, this is a video, right? So you can always pause the video, right? If you're trying to take notes and you're getting a little behind, it's okay to always pause the video, rewind it a little bit if you need to, and catch up a little, take a break. Okay, it's okay if you're watching a video, right? It's nice. What's nice about the video is you can pause it if you need to and catch up. We have 2 more laws. Okay. The next one is power of a product. And then we're going to take a look at some examples. And we're going to get to some more complex examples than maybe the ones that you have seen previously, maybe in junior high. These ones are going to get a little bit more complicated. Okay, the next one is the power of a product. And that's where you have a product of 2 different bases. okay, raised to an exponent. Okay, so now we're talking about two different base numbers. It's different than the other laws we've been looking at. Okay, so for this one, you can actually separate them and raise them separately to that exponent. Okay, so if I had like 3 times 4, let's just say squared. Okay, so 12 squared. You could separate the 12 into a 3 and a 4, and then you'd have 3 squared times 4 squared. And at first appearance, you're kind of like, I don't really know why I would use that, right? I know what 12 squared is. But sometimes it's more complicated numbers than that, and it actually helps to be able to separate them. And we'll do some of those down the road. Okay. And then the last law is the power of a quotient law. Okay, similar thing, you've got like a fraction of 2 different base numbers raised to an exponent. Okay, you can do the same thing. You can separate them and raise them to that exponent. This one's a little clearer to see because if I had, say, 3/4 squared, I don't know what 3/4 squared is, like necessarily off the top of my head. I don't really know, right? But I might be able to do it differently if I separated the 3 squared and the 4 squared. I have a different way of calculating this because now I can do 9/16. It's 9/16. Okay, that's what 3/4 squared is. Okay, so it gives us another way of being able to calculate that number. Okay, so there we go. Those are all of our exponent laws. Okay, and what we're going to be doing is we're going to be starting out with kind of some simple ones, and then we're going to be getting into some more complex ones, and you'll find that's the case as we head through this particular section of our chapter 1. Okay, so if we start with just some simple ones, say like x to the 4th, x to the 11th, right? For that, you have the same base, they're both x's, so you can just combine those exponents, and you get x to the 15th. What if I have y to the 4th and y to the -7th? Okay, again, you use that same law. You combine your exponents, though, and you get y to the -3rd power. And at first you might think, oh, I'm done, right? But you're not done because, like I mentioned a minute ago, you can't leave a negative exponent in your answer. This is not fully simplified yet. Okay, to be fully simplified, to be done with the problem, you need to get rid of the negative exponent, and you do that by changing its place in the fraction. In this case, numerator to denominator. And now you're done. Okay. Let's try this one, 3x cubed. Okay, this problem, believe it or not, is one of the most missed questions I get. Okay, and the reason why is because we're going to take this base, these two bases, the 3 and the x, and we're going to raise them both to the 3rd power, right? So it's going to be 3 cubed and x cubed. And here's what, for some reason, I don't know why, this particular number, 3 cubed, is not 9. 3 cubed is 27. So it's 27x cubed. But for some reason, there's something about the combination of 3 and 3 that we all want to say is 9, but it's not. It's 27. Okay. So when you get that particular problem, 27. Okay, but you got to cube the number part and the variable part. Okay. Now let's get to some more complicated ones. Okay. Let's do 2a cubed b squared times 3a b to the 4th cubed. Okay, we'll do this one together, and then I'm going to give you another one and have you pause the video and have you do it. Okay, so for this one, the first thing you're going to do is you need to get rid of those parentheses on this second part of the problem. Right, so there's that 3 to the third again, right? Okay, so let's simplify that second part, right? So we're going to do 3 cubed, a cubed, b, power of power rule, 4 times 3. So that's going to be a 12. Okay, now I do know what 3 to the third is. It's not 9, it's 27. So I'm going to go ahead and I'm going to change that to a 27. Okay, now we're going to combine these two parts into one single expression before I'm done. Okay, so I have an a cubed and an a cubed. Okay, so when I combine those two, it's 3 plus a 3, so it's a to the 6th. I have a b squared and a b to the 12th. So when I combine those two, I add the exponents and I get b to the 14th. Okay, now the numerical part in front, the 2 and the 27, right? The numerical part, this isn't part of the exponent laws. Those numbers in front, they don't have exponents. So you actually just treat those like you normally would. So it'd be 2 times 27. Okay, so that would be 54. And that is your answer. Okay, so I'm going to give you one, and then I want you to pause the video, and I want you to answer this one on your own, and then turn the video on and see if you got the right answer. So let's do 5a cubed b squared times 2a b to the 4th, and that whole thing is cubed. Okay, now you're going to pause the video and you're going to solve it, and then you're going to turn the video back on and see if we get the same answer. So pause the video. Okay, so let's see if we get the same answer. Okay, we're going to tackle this one the same way we did the last one, where we need to take care of that exponent on the second part of the problem. Right, so this first part is going to be the same. And the second part, we're going to distribute that cubed through there. So we're going to do 2 cubed, which is 8. A to the first power cubed is a cubed. And b to the 4th cubed is going to be 4 times 3, which is 12. Okay, now we're just going to combine those two. We're multiplying them, so that means we add the exponents. Okay, so we have an a cubed and an a cubed. So we're multiplying those two, so that means we add the exponents, and we get a to the 6th, and then a b squared, and a b to the 12th. That would be a b to the 14th. And then the numerical parts, we just multiply like we normally would. So that's 5 times 8, 40. Okay, did you get 40, a to the 6th, b to the 14th? Okay, I bet you did. Okay, let's look at a couple other little sneaky things, right? Dealing with negative exponents. If you have a fraction that's raised to a negative exponent, you could distribute that negative exponent through that fraction, right? And you'd have a to the negative n, b to the negative n, and then you have to deal with 2 negative exponents. Or you could save yourself a little work, and you could just flip that fraction and make it a positive exponent. Okay, you'd still get the same result as if you distributed that negative exponent and then had an a to the negative n and a b to the negative n, and then took care of both negative exponents. But this is a little easier, right? Because we just got rid of the negative exponent right off the bat. Okay, so it just kind of helps. So let's say you have like a 3/4 to the negative 2. Rather than say 3 to the negative 2 over 4 to the negative 2, making more negative exponents, just do this. So 4 over 3 squared. Just flip your fraction and change it to a positive exponent and save yourself a little work. Okay. And if you had, say, a fraction with two negative exponents, right? Then right off the bat, just change their positions and get rid of those negative exponents. Okay, we don't like those negative exponents. Okay, now to finish off today, let's do a couple problems that have negative exponents. Okay, let's say we have 6st to the negative 4th over 2s to the negative 2 power over t squared. Okay, what I like to do when I see these problems that have negative exponents is just like get rid of those first and then simplify the problem. We can't have any negative exponents in our answer, so we know we have to handle them anyway. So just take care of those first. Okay, so in this case, I'm just gonna go ahead and write down the things that are positive, right? I have an s and a 6 and a 2 and a t squared. Those things are fine, I'm gonna leave those be. And now I have a t to the negative 4 power. I don't want that negative anymore, I wanna make it positive. So I move it to the bottom and make it positive. Okay, so now I took care of that. And then on the bottom, I have an s to the negative 2 power, and I want to make that a positive exponent. So I move it up to the top and make it squared. Okay, see what I did there? Right? I just got rid of the negative exponents right off the bat. Okay, and now I'm going to simplify stuff. Okay, for instance, 6 divided by 2 is a 3. On the top, I have an s to the 1st power and an s squared, so I can combine those to make it s cubed. And then on the bottom, I have a t squared and a t to the 4th, so I can combine those and make it t to the 6th. And I'm done. Okay, let's do one more. I'm going to have you guys pause the video and see what you can get with it, and then we'll be done. Okay, let's say that's your problem. I want you to pause the video and let's see what you get. And then we'll turn the video back on and see if we get the same answer. All right, you're playing the video again. So let's see what you came up with. Okay, well, the first thing I would do is I would get rid of the fact that that exponent is negative. And we talked a few minutes ago, right up here, about how if you have that negative exponent for a fraction, you can just flip it and get rid of the fact that it's negative. So I would just do that, right? So instead I would make this 3x cubed over y and make that a positive 2, and now we don't have any negatives. They're gone. Okay, so now we just have to square everything, right? So it's gonna be 3 squared z cubed squared, power rule would be 3 times 2, so 6. And on the bottom, y to the 1st power squared, y squared. So the only thing left there is we do know what 3 squared is, right? 3 squared is 9. And that would be your answer. Did you get the answer? I hope you did. All right. Okay, that is it for our laws of exponents review. I hope it is all pretty familiar and we're ready to move on. Thanks, everybody.